about the isotopes and isobars we will discuss today.
Yes, sir. So can I tell
Okay.
what isobar is?
Don't repeat, I will say no.
Okay, sir.
Okay. Isobars. Isobars means what we can say. The species which have same mass number but a different atomic number. Okay, the species which are having same atomic mass number but different atomic numbers. For example, what we can say,
Okay.
uh, argon 1840, calcium 2040, and potassium. Potassium atomic mass how much? No? 1940. So if you observe in these three molecules, what we are getting? So molecules which are having same atomic mass number but different in their atomic number. So these all three together called as isobars we can call. Okay. Next after isobar, we are going to discuss about the isotones.
Sir, potassium is 40 or 39?
40 also there, 39 also there.
Okay, sir.
Isotones means what? The species having different atomic number and different mass number but having same number of neutrons. And you don't know how to take neutrons?
Yes, sir. Yes, sir.
Example, what we can say, carbon 614, nitrogen 715, oxygen 816. In this one, how many neutrons are there?
8, sir.
8, sir.
And in this one also 8 neutrons. And in this one also we are having 8 neutrons. Number of neutrons is there. Okay. And next one we are going to discuss about the isoelectronic species.
Sir,
Isoelectronic species. Tell me.
sir, the isotones are in nature only, sir.
Come again.
So isotones are naturally occurring.
Rare. These isotopes, isotones are there, no? These are all species only, and among the species we are trying to find relations. Okay. So depends on that
Can
only
you
we are
move to
going
the
to use
previous?
these isotopes, isobars, isotones in the nuclear chemistry topic we are going to use.
Sir,
Sir, can I?
Okay.
sir, you told that potassium can also have atomic number 40, no, sir?
Atomic number, nine, atomic mass.
Oh, okay, sir.
Isoelectronic species means what?
Same number of
Sir,
electrons.
can you go to previous?
The species having same number of electrons.
Serious.
Done?
Yes, sir.
So example what we can say, O minus 2, F minus N minus 3, Mg plus 2, Al plus 3. These all having how many electrons? O minus 2 means how many electrons will be there?
plus 2, sir.
N, sir.
Oxygen means what? 8, no? 8 plus 2 means 10 electrons will be there. And in F minus
9 plus 1, 10.
F,
10. And nitrogen
7 plus
10
3,
electrons. And in Na plus
7.
11 minus 1 10 electrons. And Mg plus 2 10 electrons. Al plus 3 also 10 electrons. So having same number of electrons, right? Same number of electrons. So these are called isoelectronic spaces. Okay. So depends on this concept. I will give you one question. Try to solve this, Nana.
Sir.
Hmm?
So we can say that elements are isoelectronic species when we write their oxidation number, right?
In terms of oxidation number only, we will find out, no?
Okay, sir.
Because ultimately, to get same number of electrons, so some electrons has to be gained, some electrons has to be lost, no?
Yes, sir.
Question say, the number of electrons, protons, and neutrons in a species are equal to 18, 16, 16. Assign the proper symbol of atom.
Sir, assign spelling you wrote wrong.
ASSIGN, right?
Yes.
Assign the proper symbol of the element. Tell me.
Sir, the atom charge minus
P, sir. Sir, P, sir.
Huh? What is the
Sir,
atom
let's
that we
take
need?
the atom A. A minus 2 is the answer.
Excuse me. Okay. So I'm asking the atom element also. Because
sulfur,
once you know the
Phosphorus,
atomic number, so you
phosphorus.
can predict that one also. Tell me.
Sir,
sulfur,
phosphorus.
sulfur, sir.
sulfur, sir.
Very good. So how many neutron protons are there? Simply electrons are 18, right?
16.
Electrons are 18 and protons are
As ex-
Electrons are
16.
18, sir.
Given and neutrons
You
also.
wrote electrons 16, sir.
Huh?
Electrons are
You
18, sir.
wrote 16, sir.
You wrote 16.
Electrons are 18 and neutrons are 16. So proton 16 means we know which atom atomic number 16. Atomic number
Yes,
16 means what? Sulfur, no?
Yes, sir.
Yes, sir.
And 80 electrons means sulfur, it will have neutral atom, it will have 16
Minus,
protons and 60 electrons. So
Sir,
by
minus.
taking 2 electrons, it will have minus 2. And it's supposed to be S minus 2 means what should be the atomic mass of sulfur should be
Sir, 32.
32.
Sir, I have a doubt.
32, sir.
Okay.
Sir,
Tell me.
sir, that means in this you wrote 10 electrons, no, sir. Isoelectronic species.
Uh,
That means we can put Ne also, sir, neon.
Any also you can write.
Or it
Sir?
should have a charge, sir.
It's not necessary. Okay, it should have charge or anything. It can be neutral molecule also.
Okay, sir.
Sir, mass number and atomic number both are same, no, sir?
Who is asking? Mass number and atomic number both are same. What we have had yesterday, yeah?
Session.
Sir, once can you go to previous slide? 1 minute, sir. Sir,
Tell me.
sir, that means in this question, you wrote, no, sir. The assign the proper symbol of the element means what, sir?
Proper symbol means the element with atomic number, atomic mass, and charge he is asking.
That means you wrote symbol only, sir. Like we had put charge in the place of atomic
Actually,
mass.
proper element means what we can say. So with mass, everything we will represent, no, generally.
Yes, sir.
Uh,
Okay, sir. Okay, sir.
Next one. So after this, okay, we are going to discuss about the atomic models. In atomic models, the first atomic model is what?
So Dalton.
J.J. Thomson model. No?
So, but so we had Dalton's also, right? So the pool ball model.
Okay, first model is J.J. Thomson model, right? So once after discovery of electron, proton, and neutron, okay, sorry, in Rutherford and even in Bohr's theory, still Bohr's theory, their neutrons were not discovered. Okay, up to that only electrons and protons only discovered. In J.J. Thomson model, what we are going to discuss actually, according to this, he proposed that atom is a positive sphere. Okay, he has proposed that atom is a positive sphere like us. For example, if I'm taking this is atom, right? So this is what a positive sphere. So as they had saying that atom is positive sphere means that means he is considering that in the atom all the protons, okay, all the protons will form a positive charge. All protons means what? All positive charge together it will form a sphere. So into that sphere, the electrons will be placed in such a way. Okay, the electrons are placed. These are electrons actually. Okay. He proposed that atom is a positive sphere and electrons are embedded into the sphere in such a way that the molecule gets electrical neutrality. That means he is trying to say that once after arrangement of all the positive atoms into a sphere, okay, the electrons can be placed into the atom in any manner so that the overall positive charge should be equal to overall negative charge. So if positive charge and negative charge are equal, so they both cancel each other and they will form a neutral molecule. Okay, they will call neutral molecule, we can say clearly. Now from this one, see.
Sir,
Uh,
sir, that means they are just assuming.
this is completely assumption. There is no theoretical proof for this one. Okay. That's
Okay,
why
sir.
this model is also called as
Plum pudding model.
plum pudding model.
Or watermelon model.
Watermelon model.
Plum pudding model or
Watermelon.
Watermelon model.
okay.
So even
Okay.
the blueberry muffin model.
Um,
Sir,
mm.
sir, you wrote a molecule, sir, in such a way that the molecule gets
Molecules
electrically.
are electrons.
Molecule?
Electrons are embedded. I had written here.
No, sir. You wrote electrons are embedded into the sphere in such way that the molecule you wrote,
Uh,
sir.
molecule also you can share that the atom also you can
Yes,
write.
sir. That only.
That the atom gets electrical neutrality.
Okay, sir.
Done. This is Thomson model. But whereas when alpha scattering experiment was proposed, so this theory was rejected in 1911 or 1912. Okay, because when alpha scattering experiment was done, no, so in that one this theory was ruled out because there is no proof for this one.
So it was actually an accident, right? The alpha scattering model.
Yes.
So because Rutherford was just trying to like see another nuclear atoms element, but he found this.
Actually, he want to do something, but
Sir,
accidentally he
alpha
got this
scattering
model, right?
experiment means
Yes, sir.
Rutherford scattering experiment.
Same that only alpha scattering experiment, Rutherford model,
Okay.
all everything same only. Next one is Rutherford atomic model, which is also called alpha scattering experiment. Okay, Rutherford atomic model are simply we can say alpha scattering experiment. So this was proposed in 1911. Okay. So in that one, what he has taken? Next one. So in this alpha particle, so what is alpha particle
The
generally?
alpha particles are positively charged particles shot out of a nuclear box at that point of time.
Boop Singh. Okay,
Yes.
if you know, please quiet, right? Because we
Okay,
have other students, right?
okay, sir.
See, so alpha particles means
H
alpha
plus 2, sir.
particles I told you to Boop Singh, and I'm telling to everybody, those who know, no, please be quiet. Alpha particles are the particles having 2 units of positive charge, positive charge, and mass is 4 times of proton. That is helium 2 4 particles only. We are calling it as alpha particles. Okay. So when what he has taken for that one, he has taken a source of alpha particles. He has taken, and that source he has taken as a radium element. He has taken. Okay. So what has taken? He has taken some source of alpha particles. Let me take like this. Okay, this is what I have taken. Source of alpha particles. That is radium he has taken. Please mute yourself. And he has taken one slit also. Slit means to have single direction of wave. And he has taken one thin gold foil he has taken. Okay, thin gold foil he has taken, which is surrounded by, okay, which is surrounded by a fluorescent screen he has taken. Fluorescent screen. And here this gold foil is there, no? This is what we can say. It is like a matter of study for his experiment. And here why gold foil only used?
So can I tell?
Foil is used. Tell me.
So it is because nowadays it's very hard to get such a thin gold, such a thin foil cell with other metals. So that at that point of time, so when he was doing the experiment, gold was the only metal so that could be so malleable, and you could get such a thin sheet, sir. Because if you get a bit thick sheet, sir, you might not get accurate results. Like the alpha particles might have bounced off. Like the
Alpha foil is used because of
its malleability, sir.
okay, because of high malleability. Okay, so because of why he made thin shades, because from that one he can observe that. Okay, we can observe that. So when this high malleable sheet is there, no, so the alpha particles can penetrate through these particles. So in this one, see, so these are the alpha particles from the source of radium. Alpha particles are passes through this kit. So when it is passes through, no, he observed, and a fluorescent screen how we are going to use whenever light strikes on this. Okay, whenever light strikes on the surface,
Real glow, sir.
one tiny flash we are going to get. That tiny flash we are going to say fluorescence. Okay, so whenever the whenever the alpha particles are alpha rays, or you can say, or alpha particles, you can say, no issue, alpha rays are passes through, he observed that most of the alpha particles are passes through the foil. Okay, some of the alpha particles are passes through the foil, and very few particles are bounced with small angles like this. and very few particles are bouncing back like this. So when alpha particles are passes through the gold tin foil, he observed that, okay, from that one he made certain experiment observations that most of the alpha particles are passed through without any change. Okay.
Sir,
From that, tell me.
sir, that means he took radium.
Radium.
Sir, here I
Complete
have a
no.
doubt.
Complete no. Radium tak I had.
Sir, I have a doubt. So what does it mean by 2 units of positive charge, sir?
Mass number, atomic number 2.
Oh, okay, sir.
Sir, sir, that means alpha rays means they have 0 electrons.
How come here 2 protons means 2 electrons will also be there? No.
No, sir, that means it is He.
Can you please tell me any particle which is having only 2 protons without electrons? Okay.
Sir, I
So
have a
from
doubt.
this one,
Sir,
tell me
sir,
Anna.
we can write this or not?
Which one?
Oh, uh,
Sir, I have a
this
doubt.
or not? We
One
have to
second.
write it.
1 second. Let me speak one by one.
Sir, we
Sandhya,
have to
where?
write it.
Yes, write it
Rutherford,
down now.
Rutherford experiment.
Write it down now.
Yes, sir.
Mm.
What does the red rays indicate?
Red rays, not. These are deflected rays. Okay.
Uh, alpha particles deflecting with
These are the
different angles.
deflected particles. Deflected alpha rays.
With different angles. Okay, sir.
Deflected with deflected alpha
Small
particles.
angles. Sir,
And this green color will represent completely
bounce
radiation, and
back.
blue color it will be most of the particles are passes through.
Sir,
Tell me.
sir, can you show that slide?
Uh,
Yes, sir. Sir, in alpha particles, there will be 2 protons, sir.
huh.
Sir, and what you during the alpha rays, what are the 2 white boxes, sir?
This is not white boxes. This is slit. Slit means light can come in any direction. No, like this it can go. No,
Yes, sir.
but if you are using slit, no, so it will go to uniform direction. It will go that
Only 1 point.
one direction.
Okay. Thank you, sir.
So now say. So from this experiment, what it was observed, that was observed that from the observation, okay, from the experiment, okay, it was observed that what we can say,
Many particles pass.
most of the alpha particles
Pass through the foil.
passes through the foil. And next, what we can say, few alpha particles are
Deflecting with small angles.
deflected with small angles.
A little of them bounce back.
Okay, and next one what? Very few particles are.
So 1 out of 10,000 particles, sir.
Which one, Anna?
1 out of 10,000 particles, sir.
Yes, yes, yes. That's the reason I had written very few alpha particles are bounced back. Okay. So as we are taking bounced part means alpha particles are positively charged particles, right? And as it is hitting on the positive charge, so that they will get bounced back, no? That means from there he observed that. Okay. From that one, it let me write the conclusions. Conclusions means what we can say. As most of the alpha particles are passes through, that means he observed that, okay, in an atom, most of the space is hollow, which is also called empty. Okay. Hmm. And next one, what he said, that next point he said, and very few particles are deflected, okay, with very bounce back, no, simply we can say, as alpha particles are positively charged particles and they are bouncing but means heat. For example, this is a positively charged particle and this is also positive charge is moving like this. So whenever it is hitting on this, whenever it is bombarding this, so
It
immediately
will
what
repel.
it will repel and it will come back, right? And the
Yes,
passes
sir.
which are the particles which are passing are what? Positively charged particles. So from that one he is saying that
There are few positively charged particles in the atom.
Shashank, please quiet. Mm. In an atom, the positive charges is completely is concentrated in an atom. The positive charge is concentrated in small region only. Okay, the small region only we are calling it as a nucleus. Okay, so he was the first person who gave position of a nucleus. Okay.
Sir,
Uh, next
sir,
one. Tell me. Anna.
sir, is the conclusions completed?
No, no. One more conclusion is there. I will tell you. Okay. So once after the nucleus, it was there. No, he said that. Okay. So he came to know that around the yes, nucleus is there. In the nucleus, there will be positive charge will be there. So positive charge means what? Protons will be there or not? That means he said simply protons are going to present in the center of the atom. That center of the atom only we are saying that nucleus. Okay. Now that around the nucleus,
IIT.
around the nucleus, Ray Shashank, mute yourself. Okay, around the nucleus, electrons will revolve. Okay, revolve just like how planets revolve around the sun.
Oh, sir, what is the effect of this?
1 second, Anna. The sun. Okay. Mm. That's why this model is called. That's why this model is called.
Planetary model.
Uh, model is called planetary model.
Sir, once can you show the previous slide?
1 second.
Sir, planetary spelling you wrote wrong.
What I have written?
Planet, sir. Netary.
NETA, no?
Yes, sir.
TARY. Mm.
Sir, what is the effect of revolving electrons revolving around protons?
Actually,
I
see,
mean,
there is no effect of this. Actually, whenever he is thinking, no, so he said that actually, so in atomic models, the main basic thing we are discussing are the thought was, so once after discovery of electron protons, how the electrons, protons, neutrons, or electrons, protons will be present. That means where they are trying to present. Okay, so for that purpose only there was conclusions were there, certain models were discovered. So once after discovery of Rutherford's model, no? Okay,
Sir?
so right, 1 second, let me finish now. Okay, from this one, what once after position everything came to know, and he assumed that electrons are not constant and they are not placing fixed position in any atom, just they are trying to revolve around the positive charge with a distance. Okay, that he assumed and he said, but later on he in that one also certain drawbacks also there in this theory, but in this theory or in this approach there was certain advantages also there. That is, from this one he is able to calculate the diameter of atom and diameter of the nucleus. Okay, volume of atom and volume of nucleus, he able to calculate it. So he was the first person, he assumed and calculated the atomic size of an atom and atomic that means nucleus size and atomic size of an atom he has predicted. Okay, so in the,
okay.
after that also certain scientists find out certain drawbacks in this. So in addition to overcome the drawbacks only, we are going to discuss another theory we are going to discuss.
Sir,
Sir,
1 second, understood the person who asked me that effects?
yes, sir.
Okay, next.
Sir, atom has hollow spaces, no, sir. So the alpha particles went through easily.
Yes,
Atom
Sir?
has a small nucleus, so particles bounce back, no, sir.
yes, that only.
Sir, then why small angles created?
In that one also what he is saying that, for example, say if I'm taking this is positive charge, no, so this is particles whenever straight away they are hitting, no, they are getting bouncing back. Okay, in this region it is positive charge, no, for example, if this areas it is hitting, so obviously it will deflect only, no.
Yes, sir, understand.
That's why.
If it
sir,
hits
Okay,
the center of the nucleus, then bounce back. Any
uh,
other part of the nucleus with angle.
it will just deflected with small angles. Okay, please ask me one by one so that I will clear each and everyone's doubt.
Sir?
1 second,
Sir?
1 second. Sharandeep, somebody asked me, tell me, Sharandeep.
yes, sir. Sir, you told that Rutherford got these conclusions accidentally. Then why did he conduct the experiment, sir?
Come again, what you are trying to say?
Sir, you told that Rutherford got these results accidentally.
Not
So,
see, listen. So the intention of performing this experiment is to study the nuclear effects of an atom. Okay,
okay, sir.
that is his motto. So for that one he planned like this. So by doing so he observed different points. From there he discovered this model. He was not intentionally trying this experiment to what we can say, to identify atomic models and everything.
Okay,
Understood?
sir.
uh, Tell me, Ranveer, what's your doubt?
Yes, sir.
Hmm.
Sir, that means you wrote Once can you go to the slide?
Hmm.
Yes, sir. Previous slide, sir. Sir, that means here you wrote in an atom, the positive charge is concentrated in small region only called nucleus, no, sir?
Yes.
Sir, that means in this experiment only the nucleus is found.
Yes. Yes.
Okay, sir.
Hmm. Next. Navneet.
Sir,
Uh,
sir, in atom, the electrons are revolving around the nucleus, sir.
yes.
Then means alpha particles are passed into nucleus, sir, or anything else.
Into nucleus only it will go, no? So that's the reason they are bouncing back, no?
No, sir. What about electrons? They passed or not?
No, because positive charge obviously they will attract only, no? So attract
Okay.
electrons doesn't affect any alpha particles because they are trying to accept only because electrons are negatively charged particles.
Okay, sir.
Mm. Okay. Mm. So this is about the Rutherford's experiment, Nana. Okay. And one more point is there. From this one, limitations was there. So I will write the limitations. Major limitations I will write, or drawback I will write. Okay. Major drawback I will write, and after that we will close for today. You have next class as well, right? See, so this is the nucleus, and around this electrons are revolving. Whether it is revolving in a circular path or elliptical path, in how which direction it is revolving, nobody knows. Even he was also not able to explain in which direction it is moving. So according to classical physics, what we can say simply, classical law of physics, if any particle, okay, or if any particle is moving around the nucleus with a particular distance, okay, if any particle, that means he is trying to say, so electrons are revolving like this, right? So as electrons are revolving into the cell like this, so they're supposed to lose energy and then finally they fall into the nucleus. If it is happening, so atom should get collapse, but in actually it doesn't explain the stability of atom. If any particle is moving around the nucleus with particular distance, it should lose its energy and finally atom should get collapse. Okay, but actual practice it is not happening. Why it is not happening, that was not explained. And
Sir, I have a doubt.
one second, and it was not able to explain the spectrum spectra of atom. Okay, drawbacks I will tell you in next class also. If you have any doubts on drawbacks, please ask me next class, as you are having next class now. Okay, bye students.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye, sir. Bye.